Okay, now we're going to see how to program your timer by using a C language. Okay, first we look at timer 0 programming, followed by timer 1, and after that timer 2 programming. So since this one here, we are going to use the timer 0. So the TCNT that we're going to use here is TCNT 0 register. Since your timer 0 is 8-bit, thus your TCNT0 also 8-bit wide. So this is your TCNT, which is you have 8-bit wide, starting from bit 0 to bit 7. Okay, so the maximum value of your TCNT0 is 255, or FF if you're using a hexadecimal. So this TCNT0 is used as a counter for timer 0. Okay, next we're looking at the TCCRO register. Okay, the register that you're going to set your timer. All right, so the TCCRO 0 also a 8-bit register. Okay, used for control your timer 0. So this is your timer TCCR0. You have 8-bit. So in this TCCR0, we're only looking at bit 6 and bit 3. Okay, so bit 6 and bit 3 actually used for timer setting. Right, so this is a timer setting. Okay, or timer mode, actually a timer mode. Okay, the mode that you're going to select. Okay, which mode? All right, so in this case here, only two mode that we focus or emphasize or we learn. Okay, one we call it a normal mode, atau with another name called overflow method. The second one here we call it as a CTC, or clear timer on compare mesh. This one is compare mesh. All right, if you put 0 0, bit 6 0, bit 3 0, okay, you're going to use a overflow method, a normal mode. Okay, a normal mode method. If you put 0 at bit 6 while 1 at bit 3, so you're going to use it as a CTC mode. Okay, while PWM, pace correct, and fast PWM, okay, we're not going to you are not going to learn about this thing. Okay, we only focus on normal mode and CTC mode. Okay, next, another bit that you're going to know is bit 0 to bit 2. Okay, this 3 bit here. Okay, from bit 0 to bit 2. Okay, so this one here used as a prescale. Okay, if you can see here, yes, this is the first one, and then this is second one. Okay, if you put 0 0 0, bit 0 0, bit 1 0, bit 2 0, no clock source, means that you stop timer. Okay, timer stop. Okay, if you put 0 0 1, this is without a prescale. 0 1 0 means that you're going to use a prescale. 0 1 1 a prescale of 64, 1 0 0 prescale 256, 1 0 1 prescale 1024. Okay, so this one here, this is for timer delay generation. Okay, you want to generate a timer delay, you need to put this setting here. Okay, one without a prescale, the other 4 with a prescale according to this prescale value lah. You have 8, 64, 253 and 1024. Okay, if you put the 110 and 111, what happens is this is an external clock source on T0 pin. Okay, one is a falling edge, the other one is rising edge. Means that this one here you want to count an event. Okay, if you want to count an event, okay, you put this setting here. If you want to generate a delay, you put this setting here. If you want to stop your timer, you put 000 at this 3 bits. Okay, so this is what happened. Okay, this is the one that I already mentioned earlier. Okay, let's look at the TCCR0 register examples. Okay, find the value for TCCR0 if you're going to use a timer 0 normal mode with a no prescale. Okay, so what is normal mode? Normal mode, you need to put 00 to bit 6 and bit 3. What about no prescaler? Okay, previously we already learned that, okay, for the no prescale, you need to put what value? 0, 0, 1. Okay, so 0, 0, 1. So you lukis lah. Okay, so you lukis your TCCR. Okay, so this is your TCCR. Okay, sorry for my drawing. Okay, so the first one is bit 6. Okay, this is a bit 6. And this is bit 3. Okay, for timer 0 normal mode, you need to put 0, 0 here. Okay, put 0, 0 at bit 6 and bit 3. If you put 0, 1, what happens is you use a CTC mode. Okay, next, no prescale. What is the no prescale value? 0, 0, 1. Where you need to put this 0, 0, 1? At bit 2, 1 and 0. Okay, you bit 0, 0, 1. So, what about the rest? The rest you just put 0, 0. So, this is how you're going to set your timer 0 by using a normal mode with no prescale. So, you write down TCCR0 equal to OX0, 1. Ataupun you can write down TCCR0 equal to 0B00000001. This is how you're going to write in C programming. Okay, example 9.2. Find the timer clock frequency and its period for various AVR-based systems with the following crystal frequency. Assume that no prescale is used. Okay, so no prescale. What the meaning with no prescale? Means that you use the same crystal frequency. If you're going to use a prescale, means that you're going to divide your frequency with the prescale that you're going to select, either 8, 64, 256 or 1024. For example lah, okay, if you're going to use a prescale 8, what happens is the frequency F you need to divide it with prescale. Okay, since this one here no prescale, means that our prescale equal to 1 lah. Okay, so by right you get back your frequency value. So in this timer you have three or four formula equation that you're going to know or memorize. The first one is T equal to 1 over F. What is this? T is your period sama dengan 1 over frequency. Okay, so frequency is your crystal frequency, or sometimes we call it as a oscillator or Xtel, or your micro P speed. Okay, that is your frequency. Alright, so to calculate the period, T equal to 1 F. Okay, for example here, okay, you have a clock frequency and its period from various AVR based systems. Okay, the first one here, the crystal frequency is 10 megahertz, no prescale. So means that with no prescale, you take the original crystal frequency value. Okay, so find the period. Okay, the clock frequency and hip frequency. So in this case here, since the crystal frequency is 10 megahertz, your F equal 10 megahertz. And what about T? T equal to 1 over 10 megahertz, equivalent to 0.1 microseconds. B, 8 megahertz. So frequency, what about your frequency? Frequency with no prescale is 8 megahertz. What about T? T equal to 1 over F, 1 over 8 megahertz. You get 0.125 microsecond. And C, 1 megahertz, frequency 1 megahertz, no prescale, so means that F equal to 1 megahertz. And what about T? T equal to 1 over 1 megahertz, you get 1 microsecond. T is your period and frequency. Okay, so this is the first equation that you're going to memorize. Okay, next, the TIFR registers. Okay, you already learned about TC and T0. TCCR0. Now we will look at the TIFR registers. Okay, the TIFR registers, or another name is timer counter interrupt flag register, contains the flag of different timer. Okay, this one here we already covers in what we call in the previous module, which is in an interrupt module. Okay, in TIFR. Okay, you see here you have a TOV flow. Okay, so this one here, all right, you see you have a TOV and N and OCF N. This N here you can replace with 0, 1, 2. All right, in which TOVs, okay, stand for timer overflow flags, while OCF stand for output compare flags. Okay, so this one, if you use an overflow, you need to see the monitor the TOV flag. If you use the CTC, you're going to monitor the OCF flag, right? So bit 0 and bit 1 for timer 0, while bit 2, 3, 4, right? So this one here, this is a for timer 1. And bit 6 and bit 7, this is for timer 2. Okay, while bit 5, you can ignore this bit here. Okay, since this one here, we will focus on timer 0. Okay, so when TOV 0 timer 0 overflow, the flag is set when counter overflow, which is going from FF to 00. When it's going to FF to 00, the overflow occurs. Okay, I menimpa, and then what happens is the TOV flag will be set. When the time roll over from FF to 00, TOV 0 flag is set to 1 and it remains set until the software clears it. Okay, so it will remain equal to 1 until you clear that value. How to clear? Later we'll see how to clear the flags. Okay, so that the flag become 0 again. So in normal mode, the content of the timer or counter increment with each clock. Okay, these clocks here depend on your frequency. Okay, so this frequency here, by using this frequency, you can get your T. Okay, so the value, the content of the timer will incremented based on your period area. Okay, it will count up until it reach its maximum of FF. Why FF? Because it is a 8-bit wide. Okay, your timer 0 is a 8-bit size, so the maximum value is FF. When it's roll over from FF to 00, so the TOV0 flag will be set 1. Okay, so this is your TCNT0 and this is your time. Okay, so the TCNT will keep incremented until it overflow. Okay, once it overflow, what happened here? One is overflow here. Okay, I'm limpah, which is the from FF to 00. What happened here? TOV0 will be set 1. Okay, and then you're going to start again lah. Okay, how to start again? You need to load again the value of TCNT and then clear your TOV flag, and it will keep repeating. Okay, you keep generating the what we call here the value lah. Okay, you keep generate your delay. Right, so this is the step to program in timer 0. Okay, for this one here, we focus on the normal mode first. Okay, first thing first, you're going to load your TCNT0 register with the initial count value. Okay, so first step, load TCNT value. Okay, so this TCNT, how to load the TCNT depending on your calculation. Okay, later we will see what are the calculation involved in order to load to determine what is your TCNT value. Right, then the second step here, what you're going to do is, okay, for the timer programming, okay, you just follow this step. Inshallah, you will know how to do the timer program. Alright, so first load your TCNT. Okay, how to load TCNT based on your calculation. Step number 2, okay, then okay, do your TCCR setting. Okay, depends on your setting lah. Either, okay, in this part here you have timer mode that I'm going to use. Either you're going to use the overflow or CTC mode, and the second one here, if you're going to use a pre-scale or without a pre-scale. This is your TCCR settings. Okay, so you need to know lah, this is your TCCR register. Okay, so bit 6 and bit 3 will determine your mode. If you put 00, it is a normal mode or overflow. If you put 01, you're going to use the CTC, while the last 3 bit here is your pre-scale. Okay, this one is for pre-scale. And then step number 3, monitor your TOV flag. Okay, so step number 3, monitor TOV flags. Okay, if when your TOV flag is raised, what happens is you'll get out from loop. Alright, if the TOV still remains 0, so you keep monitoring. Okay, how to monitor your TOV flag? Okay, you can write down, okay, this what we call this instruction here, this line here. Okay, while TIFR end with, okay, this is the value that you're going to see. Okay, since this one here, okay, we're going to program timer 0 in normal mode, so we're going to see the TOV0 flags. Okay, so if you go back to your TIFR, okay, so this is your TIFR, TOV0, the location is your TOV0 at your bit 0. Okay, that's why TIFR end with 0x001. I want to see whether my TIFR end with 001 equal to equal to 0. If equal to 0, I will keep monitoring. If equal to 1, what happen is I will exit from this loop. Okay, so that's why I put 0 at 01, which is 0 at 01. If you put the value here 0 0 0 0 0 0 0 1, I want to monitor this TOV0 flags. Okay, so this value here you need to change according to what you're going to monitor. Right, next step number 4, stop your timer. How to stop a timer? Okay, so to stop a timer, you just write down TCCR0 equal to 0. Why like that? Okay, if you put here, okay, so this is your TCCR. This is your TCCR kan? Okay, if you put 0 0 0 0 and this one also 0 0 0 0, you see at your prescale when 0 0 0, what happen when prescale 0 0 0? Timer stop. Okay, we go back to our TCCR. Mana kita punya TCCR? You see, when you put 0 0 0 at bit 2, bit 2, 1 and 0, what happen is no clock source, which is timer or counter, stop. This is how we're going to stop our timer by putting TCCR0 with 0. That is step number 4. And step number 5, okay, clear your TOV flags. How to clear your TOV flag? Why we need to clear your TOV flag? Because just now, okay, when the overflow occurs, TOV is set to 1. Okay, and then the this TOV0, the value of TOV0 will remain until you clear your TOV. So how to clear your TOV0? Okay, to clear the TOV0, you just write down something like this, TIFR. Since your TOV inside of your TIFR, you just put 0x0. Okay, you need to put 1 to your TOV0. Okay, so this is how you're going to clear your TOV flags. Okay, this is a special case. Okay, for your flags, in order to clear it, you need to put 1. You cannot put 0. If you put 0, means that the value is still there. If you want to clear, you need to put 1. Okay, since our TOV0 is location here. Okay, so this one here, if you write down in hexadecimal, it becomes 0 1. Okay, so make sure that the value is correct lah, according what flag you want to clear. And last but not least is step number 6. Okay, you're going to load your TCNT. Okay, which is repeat step 1 if you want to generate the same delay over and over. So as I mentioned earlier, okay, to load your TCNT value, you need to do a calculation. So how to do that? Okay, how to load TCNT value? Alright, to do that, first, what you're going to do is, the first equation here is T equal to 1 over F. Okay, you need to find your period. What is your period? Depend on your F. Okay, depend on your external value. Once you get your period, right? Next, the second formula that you're going to memorize is delay equal to count multiply with your period. Okay, you have the period and then you have the delay. Okay, usually the question will ask, okay, you are going to generate a 200 millisecond delay with an extel of 1 megahertz, for example. So do your programming. Okay, so you have a delay, and then from that frequency you obtain your period. Now you can get what is your count. Okay, count is how many count in order to generate the delay. Okay, so in this case here you can simplify count sama dengan delay over period. Okay, once you get your count, okay, the third formula that you're going to memorize is TCNT equal to FF. Okay, this is only valid if you're going to use overflow method. Okay, TCNT sama dengan FF minus with count plus 1. Okay, this the third. Okay, so only valid you're going to use the overflow method, so you can get what is your TCNT value. Okay, FF tolak dengan count. Okay, so make sure that your count in hexa as well, plus with 1. If you're going to use the CTC method, okay, there is another formula that you're going to memorize, okay, in which OCR equal to TCNT plus count minus 1. But usually in the CTC method, okay, the counter register will always set to 0. Okay, recall back your water bottle for the CTC. What happened when your CTC, okay, what happened for your bottle? Okay, what is the initial value of your bottle? You need to make it empty, which is your TCNT should be 0, and then you put your OCR, which is your level. Okay, you put level. So this one we're going to find what is the water level that we're going to set. Okay, by putting the TCNT 0, which is we empty the bottle first, plus with count how many count to generate a certain delay, minus with 1. Okay, so this is the formulas that you're going to memorize. Okay, so let's look at the example here. So in the following program, we are creating a square wave of 50% duty cycle with equal of portion high and low. Okay, you're going to generate a low and high signal, which is a square wave. Okay, this is 0, 1, 0, 1 with the same, with the same delay or period. Okay, this is a delay of period of your square wave, T of your square wave. Okay, so you're going, okay, this square wave here, okay, will be created, okay, at the port B pin number 5 by using a timer 0 to generate a time delay. Analyze the program. Okay, so let's lukis kita punya Microprocessor. So this is port B5. Okay, I just assume this is port B5. So this port B5, I want to generate a square wave. Okay, since this is a port B5, so I need to make sure that my port B5 here become an output port. Why output? Because I want to generate a delay here. Okay, so I include hashtag include avr slash io dot hash and then void to delay. So this is my subroutine to generate this delay here. Okay, the delay of my square wave. Okay, I name it as a T0 delay. You can name it any things you want. Okay, any name you want. Okay, but make sure that this name here must similar to this subroutine name. Okay, so I start with int main void. Okay, and then ddrb put 1 to bit number 5. What happened here? I make my port B at bit number 5 as an output port, or I can put ddip sama dengan oxff also can. Okay, and then port B equal to 0, so I send 0 value to my port B first, so I generate the low level of my signal, and then after that I toggle that 0 so that it becomes 1. Okay, so while 1, open curly bracket and close curly bracket, port B equal port B. Okay, and then this is exclusive OR with 1 shift to the left by 5 times. Okay, so I always toggle my port B. When port B is 0, it will become 1. When port B5 is 1, it becomes 0, and it will keep repeating toggles. And then next, I call my delay, to delay. So this is my delay punya subroutine. So in this case here, okay, I just focus on this delay subroutine because in this main program you already know how to write your main program. So I will not focus on this one. So in this timer programming, I will focusing more on this delay subroutine. Okay, so TCC and T0 sama dengan OXF2. What happened here? Okay, so what happened here? I put. Okay, so this is my bottle, water bottle. Okay, I put my water dekat mana? Dekat F2. Okay, so this is what happened. This is the first step. I load my TCNT. Okay, with F2. So this is the first step. Load TCNT. And then the second one, the second step here is set. Okay, TCCR0 sama dengan equal to OX01. What happened here? Okay, you see this is your TCCR0. Okay, and then you put this value here, 0, 1. Okay, 0, 0, 0, 0, 0, 0, 0, 1. Okay, now I know that. Right, this is bit 6 and bit 3. Okay, now I know that I use a normal mode because bit 6 and bit 3 is 0, 0. Okay, so this one here, 3 is 0, 0. So normal mode. So this is not 0, this is 1 because 0, 1. Okay, what about at my last 3 bit here? So this bit here, 0, 0, 1 means that I use no prescale. Okay, so what is my timer setting? Timer 0. Why timer 0? Because I use the TCCR0. So that's why it's timer 0. Normal mode. What type of mode? Normal mode. Why normal mode? Because 0, 0 at bit 6 and 3. And no prescale. Why no prescale? Because I put 0, 0, 1 at bit 2, 1 and 0 at my last 3 bit here. Okay, and then step number 3. What is this step number 3? While TIFR and with OX01 equal 0, adakah my TOV 0 equal to 0? If yes, it will keep repeating. If not, it will edit this loop. So what happened here? I monitor my TOV0 flags. Okay, I will keep monitor until my water here overflow from this bottle and the TOV0 will become 1. If not, I will keep repeating, and the delay will generate accordingly. Okay, and then this step number 4. What is step number 4? TCCR0 equal to 0. What happened here? I stop my timer. Why I stop my timer? Because I put 0, 0, 0 at my last 3 bit. 0, 0, 0 means that it is a stop timer. And step number 5, TIFR equal to OF01 means that I want to clear my TOV0. So that my TOV0 got 0 value again. And then close curly bracket, and it will be keep repeated whenever I call this subroutine. Okay, so this is what happened in this programming here. Right, so this is the details lah what happened. Okay, first load TCN2 with this number here, and then TCR0 is loaded and time 0 is started. Okay, when you do a timer setting, finish the timer setting, and the timer 0 will started. Timer 0 will count up with the passing of each clock. Okay, we started with F2, TOV still 0, F3, is it overflown? No, TOV0 still 0. Alright, and then our microprocessor will keep monitoring, okay, the what we call the TOV flag. TOV F4, TOV0 still 0. When FF, masih lagi TOV flag 0 is 0. And when FF is roll over from FF to 0, what happen is TOV0 now equal to 1. Okay, so at this point, you exit your while loop. Okay, and then what happened next? Step number 4, you stop your timer lah. Timer 0 is stop, and then step number 5, the TOV0 flag is cleared. Right, so let's look at another examples. Okay, so in example 9.3, calculate the amount of time delay generated by the timer. Assume that Xtel 8 MHz. Okay, given that Xtel equal to 8 MHz. Okay, so you're going to write calculate what is the delay. Okay, so what you're going to do? Okay, first, what is our first equation? T equal to 1 over F. Okay, so according to this programming here, okay, timer setting, timer 0, normal mode, no prescale. So you're not going to use any prescale. So your F remains 8 MHz. So sama dengan 1 over 8 MHz. So what you get here? Okay, you get 0.125 microseconds. Okay, so this is your first equation. Next, the second equation. What is the second equation? Says delay equal to count times period. Okay, you already know the period, but now you're going to find what is your delay. Okay, so in this question here, you want to find what is the time delay generated by timer. Okay, since you already know that your TCNT equal to F2, you already load this value here to your TCNT. Okay, so by using this, you can get your count value. Betul tak? Okay, so by using the third equation, alright, in this TCNT sama dengan FF minus count plus 1. So count equal to FF tolak TCNT plus 1. Okay, so FF, what is your TCNT? Minus with F2 plus 1. So you get FF minus with F2 FF minus with F2, you get berapa kat sini? OD. Okay, plus with 1, you get 40. 40 is in decimal lah. If not, you get OE. Okay, so this is 14 in decimal. Alright, so this is the number of count lah that you're going to count. So what happened here? So you masukkan, you put this value here to this formula here, so you can get your delay. So delay equal to count. What is your count? 14 multiply with what is your, what we call here, delay is 0.125 microseconds. Then you get 1.75 microseconds. So this is your delay, okay, that you generate for this square wave here. Okay, means that this 0 here, what is the delay here that you generate? Okay, what is the time that you generate for this signal 0 is 1.75 microseconds, and then another, okay, 1.75 microsecond for 1, and it will keep repeating. So the period of your signal, what is the period of your signal? Okay, so you need to add 1.75 plus with 1.75. So this is T signal. I can call it as a T signal because this is the period of your signal. Period of your signal should be 1 cycle lah. Okay, 1 cycle of your signal, which is from 0 to 1. Okay, so you already know how to find out what is your period of your signal. Alright, so this one here 1.75 plus with 1.75, you get berapa ya? Okay, 3.5 microseconds. So this is the period of your square wave signal.